So let's see some examples of this. The first one, really no work to show on this one. It says, what's the derivative of 2 to the x? Well, the derivative of 2 to the x, you just simply copy and paste. You simply copy and paste 2 to the x, but if the base isn't e, you need to multiply times the natural log of the base. In fact, even if the base is e, you're multiplying times the natural log of the base. If you multiply times the natural log of e, that's just the number 1. So that's your answer right there. No work to show on that problem. It was a nice and simple problem. Let's look at the next one, 2 to the 3x. Again, to find the derivative of 2 to the 3x, you're going to copy and paste, but then you need to multiply times the derivative of the exponent. The last time we didn't do it because it was just x. And then we also need to multiply times the natural log of the base. Well, the derivative of the exponent, 3x, is just 3. So here I end up with, man, I don't know how you want to write this one. How about 3 times the natural log of 2 times 2 to the 3x? How about that right there is how I'll write it. 3 times the natural log of 2 times 2 to the 3x. So I really don't care which order you have that in. Remember, 4 times 5 is the same thing as 5 times 4. So it doesn't matter. It's commutative. It doesn't matter which order you put those things in. All right. Let's look at this one. How about the log base 10 of cosine of x? In fact, if this was written properly, you wouldn't even put the log base 10. That's called the common log, if you remember it. So it would just be log, just the log. So it's the log of cosine of x, log base 10 of cosine of x. Well, the derivative of that would then be 1 over the natural log of the base, which is the natural log of 10, times 1 over what you see, which is cosine of x, 1 over cosine of x, times the derivative of the inside, so we need to multiply it times the derivative of cosine of x. Well, the derivative of cosine of x is negative sine of x. So what do we have? Putting it all together, on top we would have a negative sine x. On bottom, we would have a natural log of 10 and a cosine of x. So, in my personal opinion, not difficult at all. It's just the only pain is remembering every single one of the parts. So be very, very careful with this. I'm going to leave it as negative sine x all over the natural log of 10 times cosine of x. And if you look in the e-text, they actually go a little bit further on this one. They just note the fact that sine of x over cosine of x is tangent of x. Look, I'm not looking for you to go any further. I don't want you to make any more errors. Of course, if you went further like the textbook did, I would give you credit, but I'm going to leave my answer in that form right there, and I would accept that on the test. Okay, how about on this one, the derivative with respect to x of the log base 3 of the square root of x over x plus 5. So again, what we need to do here is really separate this out using those log rules. So this is kind of a cool problem to me. We have division. Remember, division is going to separate into subtraction. So this would be log base 3 of, I'm going to go ahead and write it as x to the 1/2. And then it would be minus, because division separates to subtraction, log base 3 of x plus 5. Okay, and then remember you can bring that power out in front. So I need the ddx on this because I haven't taken the derivative of this yet. So this is going to be the derivative with respect to x of 1/2 times log base 3 of x minus log base 3 of x plus 5. Now I can find the derivative. 1/2 is a constant multiple, so I keep that there. Derivative of log base 3 of x is 1 over the natural log of 3 times 1 over x minus the derivative of log base 3 of x plus 5 is 1 over the natural log of 3 times 1 over what's on the inside, which is x plus 5. But then remember, we got to do the chain rule on this one. Multiply times the derivative of x plus 5. But the derivative of x plus 5 is just 1. So I'm ending up with 1 over, sorry, let me do it in black. 1 over 2 times the natural log of 3 times x minus 1 over the natural log of 3 times the quantity x plus 5. Okay. So I'm perfectly happy with this answer right here. I virtually guarantee you, in fact, looking at the e-text right now, I can see what they did was at this point in time, they got a common denominator. I don't need to see it with a common denominator. No point. It does us no benefit of having a common denominator as far as this question's asked. So I'm going to leave my answer in that form right there.